Okay, so this is the Math at Work 10 lesson on applications of area formulas. Okay, so our last lesson we just looked at the basic formulas of how we find the area of rectangles, squares, triangles, and circles, and in this lesson we'll look at some applications of how we'd use those areas in kind of real life situations. Okay, so we can start. All right, so just as I mentioned, right, so today we're going to be looking at applying the skills for calculating area to a real-world example where area would be used, okay, and we're going to continue to use conversions where necessary and always give our answers in the correct units, right? So keep in mind, a lot of these questions, they will involve still needing to put things in right units or convert from one unit to another, okay? There's not really much background here. We've already talked about all the formulas. We've already talked about all the shapes that we're going to be dealing with. We've talked about in previous lessons how we do these conversions. So this is kind of a lesson of examples of putting everything together, okay? So we'll just kind of get straight into it. So with our first example, we are going to use an example of tiling a floor. So suppose Harold must tile a floor that measures 4.4 meters by 3.8 meters. What is the area that he must tile in square inches? And B is if the tiles are 9 inches by 9 inches, how many tiles will he need? Okay, so let's take a look at how we would solve that problem. All right, so in this first one, we are given a floor with dimensions of 4.4 meters by 3.8 meters. Okay, we can assume that that's then going to be a rectangle, where the area of a rectangle is going to be our base times our height or our length times our width. Okay. However, what this question's asked us is to find the area in square inches. If we did this area just as 4.4 times 3.8, we would get meters squared, but what we want is inches squared. So what we'll need to do is first convert each of these lengths into inches. Okay, so we'll start with the 4.4 meters. So we're starting with meters. The first thing we can do is convert that into centimeters, knowing that there's 100 centimeters per 1 meter. Okay, so again, this is all just our conversions lesson, right? Start with what you have, multiply by the conversion between what you want and what you have. What you want goes on the top, centimeters, what we have goes on the bottom. Right? We do that multiplication, we get a value of 440 centimeters. Okay? Now we can use that basic conversion of centimeters to inches, and we can take that 440 centimeters, again, start with what you have, multiply by your conversion factor. What you want is inches, right? And the conversion is that for every 1 inch, it's 2.54 centimeters. Okay, so just going back to that lesson on conversions between rates, when you do this multiplication here, right, so 440 times 1 divided by 2.54, you get a value of 173.23 inches. Okay, so that's what our 4.4, right? So 4.4 meters is really 173.23 inches. Then we'll do the same thing by the same process with the other length of our floor, 3.8 meters. So we'll take our 3.8 meters, multiply it by the 100 centimeters per 1 meter, giving us a value of 380 centimeters, and then convert our centimeters into inches by, again, multiplying by this same conversion, 380 centimeters multiplied by the 1 inch over 2.54 centimeters. And when we do that, right, the 380 times 1 divided by 2.54, we get a value of 149.61 inches. Okay, so these are the values we'll now use in calculating our area. Okay, so step 1 with this was converting it into the units that we wanted. So the next thing is now to find the area. Right, so I'm just leaving those values up because those are the ones we're now going to use. Right? So now essentially what we have is this rectangle, right, where this is 173.23 inches, and this is 149.61 inches here. Okay? So our area is just our base times our height. Okay? So that's going to be that value of 173.23 inches multiplied by the 149.61 inches. We don't actually need these here anymore. Okay, and when we do that calculation, we multiply those two things together, we get a value of 25,916.994 inches. And that would be inches squared, right? Because every area calculation has a squared unit in it. Okay, so this would be our answer to A. This is the area of the floor in square inches. Okay, if this asked us to round to the nearest square inch, we would round this up to 917. Okay, part B then gives us that we're going to be putting tiles, right? So we're going to be tiling the floor with 9-inch by 9-inch tiles. Okay, and we basically want to see how many of those tiles am I going to need. All right, so you know, if you're really ambitious, I guess you could take these lengths, right, and start counting by nines until you got up to the value that you'd need, and do the same thing with this length here and start counting by nines until you got up to as close to 149 as you could get, and then realize you're still going to have to buy extra tiles to cut them up. The easiest thing to do here is actually just take the area that you have, divide it by the area of a single tile, then you'll know, okay, this is how many entire tiles I'm going to need with whatever extra I need to buy, right? So then you know it would all work out, and then you'd have enough tiles to be able to break up and put into the other sections, okay? So for part B, what you're going to do is take your total area and then divide it by the area of a single tile. So the first thing we'll do is figure out what is the area of a single tile, right? So this is part 1B. So a tile is 9 inches by 9 inches. So the area of a tile, it being a square, right, is 9 by 9, right? So 9 inches times 9 inches, or just 9 squared, and that's 81 inches squared. So the number of tiles is going to be found by taking the area of the floor and dividing it by the area of a tile. Okay, so the area of the floor, which is what we found out in part A, right, and again, the units would have to be the same, right, so that's why we needed that area of the floor to be in inches squared, because the area of the tile was also in inches squared. So we use our area of our floor, which we had as 25,916.94 square inches, and we're going to divide it by the 81 square inches per tile. Right, and then essentially what happens here is your inches squared and you're just left with number of tiles. And when you divide this, you get a value of 319.96, right? Obviously we can't go to the store and ask for 319 and then 96% of a tile. We're just going to have to buy the next one up, okay? So we would say we need 320 tiles. And we will have a small portion of a tile that will not get used, right? Even if this was down to like 319.1, we would still round that up to 320 because you need more than 319. As long as you get something after this decimal, you need an extra tile in order to be able to finish tiling the floor. Okay, so that's our answer for 1. Okay, again, the answers are here as well for people who just want to look at the slides afterwards or can't stream the video, so it is there. Okay, so we're moving on to example 2 now. So in example 2, what we're going to focus on is something we kind of touched on in the last lesson, but we're going to look at it in a bit more detail, is being able to convert between units. Okay, so in that last example, number 1, I had to do some interesting conversions right at the beginning, right? Because the dimensions I was given were meters, but then I was asked for what's the area in square inches. So I had to take my dimensions, both of them, and convert them into inches using 2 separate conversion factors. What would be nice, and this is another way we could have done this, is taken the area, using it just from the meters, and then once you get it in meters, then do the conversion rates on just the area instead of having to do the conversion rates on both of them. Okay? So last lesson I did mention the fact that the conversion rates we had done so far were all with lengths, and lengths are just a one-dimensional unit, so we only had to multiply by the conversion factor once. However, with area, because area is 2-dimensional, right, you actually have to multiply by the conversion factor twice. Okay, so when we do this example, you'll see what I mean by converting it twice. So if it's area, you have to multiply by the conversion factor 2 times because there are 2 dimensions. All right, so in this first bit, the first thing we're being asked to do is calculate the area of the rectangle in square inches. And we're seeing we have a rectangle here that has dimensions of 81 inches by 48 inches. So both are in inches, no problem there. We're being asked to find the area in square inches, so no conversions are necessary for part A. Okay, so for part A, all we need to do is say, well, the area of a rectangle is base times the height. The base was 81 inches. The height was 48 inches. We multiply those together. We get a value of 3,888. And inches times inches is inches squared. There's our answer for A. Okay? Part B asked us to convert our area from inches squared into feet squared. Okay, so again, if we did like what we did in question 1, we'd have to go back and we'd have to convert 81 inches into feet and then convert 48 inches into feet and then multiply. But I've already done the work, I've already found the area, let's just go the area from inches to feet. Okay, so what I'm going to do is again start with what I have, it's at 3888 inches squared. I'm going to multiply by the conversion factor that I know exists between feet and inches, which is that there are 12 inches in 1 foot, right, which is again what I want on the top, what I have on the bottom, but because it's area, I need to do this twice because it's in 2 dimensions. Okay, again, it also helps with like the unit analysis and the canceling, right? This is inches squared, there's 2 inches that need to be canceled out. If I only do 1 conversion factor, I only cancel out 1 of the inches and I'm left with a unit of inches feet, which makes no sense. Okay, so that's why I do it twice, that way both of these inches cancel with these 2 inches, and what I'm left with is an area of feet times feet, which would be feet squared. Right, so what I would do here is the 3888 times 1 divided by 12 times 1 divided by 12. Right, or you could think of this as a fraction and multiply 3888 times 1, right? Multiply all your numerators together, get that 3888 feet squared divided by, and then multiply all your denominators, 1 times 12 times 12, which would be 144. And then you just do the division of 3888 divided by 144, and you get a value of 27 feet squared. Okay, so 3,888 square inches is the same as 27 square feet. Okay, so again, you got to remember that we're talking about square foot. We're talking about a space that's a foot by a foot, right? When we're talking about square inches, we're just talking about something that's like an inch by an inch, right? And you can fit a lot more than 12 of those little square inches into something that's a foot by foot, because it can be 12 by 12, which is where that 2 12s are coming from. Okay. Part C asks us then to take the area and convert it into yards. So what we can do there is the same concept where I can use my 27 feet squared and then multiply by the conversion factor between feet and yards. And I know that there are 3 feet in a yard, so what I want goes on the top is a yard, what I have goes on the bottom is a foot. There are 3 feet in 1 yard, and because this is an area conversion, I need to do this twice. Right, again, so that you have feet squared, that's 2 feet, right, like feet times feet, so I need 2 of those. So these can then cancel with that, and you'll be left with an answer of yards times yards, so you get yards squared, you get area back again. Okay, so again, what you can do here is think of this as a fraction, and do 27 times 1 times 1. You get 27 yards squared, divided by 1 times 3, which is 9, and ultimately gives you 3 square yards. Okay, so there's number 2 on converting between units, right, between area units. Okay, here we go. Number 3, right, so again, there's your answers and number 3. So let's do one with a circle, right, so applying something with circular area. So in this example, Gail's family installed a portable pool with a diameter of 4 meters in their yard. They left the pool in the same place for so long that the grass underneath the pool died. Okay, so now they've taken the pool out and they want to fix their lawn, and we're being asked to calculate for them what is the area that needs to be seeded to the nearest tenth, so 1 decimal place of a square meter. Okay, so that is our, that's our next question. Okay, so we're trying to figure out the area there. So again, what we've been given in this example is a circular area with a diameter. So remember, diameter is the distance going all the way across the circle of 4 meters. Okay, now it's asking about the area. So we look up our area for our circle, and the area of a circle is pi times the radius squared. Now this value of 4 is not the radius, it's the diameter. But remember that the radius is equal to the diameter divided by 2, right? It's exactly half. So if all the way across is 4 meters, then just this is half of 4, which is 2. Right, so it's 4 meters divided by 2, so my radius is 2 meters. So when I go to do my area formula, I'm going to use the 2 meters as my radius. So area is equal to pi times 2 meters squared. Okay, don't forget your order of operations, right? Your bed mass. Exponent comes before multiplication, right? So if you aren't aware, there is a multiplication sign there, right? When we see pi r squared, it means pi times radius squared. So the first thing you're going to do is square that 2. And 2 squared is 4. Okay, and now I can take 4 and multiply it by pi. And when I do that, I get a value of 12.57 meters squared. But the question did ask for the nearest tenth of a meter, so I only want 1 decimal place. So I look at the second one. It's a 7. Since that's bigger than 5, this will bump up to a 6. So the answer that I'm going to give is 12.6 meters squared. That's the area of our pool, okay? Not the pool, sorry. It's the area that the pool covered, which is the area of the grass that now needs to be seeded in the lawn, all right? Now, if we quickly go back and look at part B of this question, it tells us that we can go out and we can buy a 1 kilogram bag of grass seed. That on the bag, it actually says it covers, the 1 kilogram bag covers 45 square meters. Will 1 kilogram bag be enough to cover the area? And in this case, all we need to do is compare what the bag has and the area that we have. So the area that we calculated was 12.6 square meters, and the bag says it covers up to 45 square meters. 12.6 is clearly less than 45, so we will just need the 1 bag, okay? And I just wrote that one out here, right? So yes, 1 kilogram bag is enough to cover the area since we only need 12.6 meters squared. The bag says it can cover 45. Obviously, 12.6 is less than 45. We have enough, right? Plenty to spare. All right. Last one. Okay, so our fourth example, I wanted to try and throw in at least an example using the triangle formula again there. So in this one, what we're dealing with here is house gables, right? So if you've ever heard of somebody talking about the gables on a house, it's the triangular part, right, of a home. Right, so the parts where you'd actually have to kind of like cut and have the angles ready to go so you knew actually how to put that siding on there, okay? So that little section is called the gables, okay? Now, what we're being asked to do here is just calculate the area of each gable shown below. So we've been given 2 triangles to look at, right? And remember that the area of a triangle formula was base times height divided by 2. So you'll notice in this diagram, right, it's very clear that the base is 20 feet. They're showing a 5-foot straight up and down height of 5 feet. They're not showing it directly in the middle, but it could easily be put there, right? And it is still fitting with our definition that this straight up and down line would make a right angle with this straight across line here. Okay, so the base is 20 feet and the height is 5 feet. Right, same thing here, the base is 32 feet and the height is 4 feet. Okay, so let's go and solve that one. We'll solve the first 2 and then we'll come back. All right, so for A, again, like I said, the area of a triangle gave us the formula of base times height, and then we divide it by 2. So in that first one, the base was 20 feet, the height was 5 feet, and then we divide by 2. So 20 feet times 5 feet will give me 100 feet squared. And then we'll divide that by 2, which means the area of the first gable of that first house is 50 feet squared, okay? We're going to do the exact same thing for the second house, where again, area was equal to base times height divided by 2 because it was a triangle. The base of the triangle of the second house was 32 feet with a height of 4 feet, which we would divide by 2. So again, what you do is you'd multiply this first. So 32 feet times 4 feet is 128 feet squared divided by 2. And 128 feet squared divided by 2 will give you 64 feet squared. Oh, my apologies for running out of whiteboard. Okay, so these are our two areas of the first two, right? So the first gable, area of 50 square feet. The second gable, an area of 64 square feet. So if we go back and take a look at part C of the question, right? It's saying the gable of the first house is to be painted blue and the gable of the second house is to be painted white. Both colors of paint are sold by the quart and have a maximum area coverage of 12 meters squared. How many quarts of paint are needed in each color? So this is another one where we need to do a conversion because we've just calculated the area of the gables in square feet, but we're going to the store and it's telling us how much it can cover in square meters. Okay, so it's our job to do that conversion. Okay, so again, we can use that information that we just talked about in terms of how do we convert areas, right? So in that first one, our first area was 50 square feet. And what we want is we want to put that into meters, okay? A quick little search and we can get that the relationship between feet and meters is that there are 3.28 feet in a meter. So what we want is meters, what we have is feet, and there are 3.28 feet in 1 meter. Right, so there's the conversion, but because I'm dealing with an area, I need to do that conversion twice. Right, so when I do that, right, 50 times 1 times 1, right, the feet squared, these 2 feet cancel with that, so I get 50 meters squared divided by a value of 3.28 times 3.28. 3.28 times 3.28, which is 10.7584. Right, and then when I do that division, I get a value of 4.65 meters squared for that first one. Right, then I do the same process with the second one. Right, so I start with the area of that gable, which was 64 square feet. I multiply by the conversion rate from going from meters to feet, which is that same, there's 3.28 feet per 1 meter. Do that multiplication twice because it's with an area, so there's 2 dimensions, so I do the conversion twice. So again, you can think of this as a fraction and do all the multiplication at the top, right? 64 times 1 times 1, and you're still left with 64, right? These 2 feet cancel with those 2 feet. Meters times meters is meters squared. And then when we do that division again, the 3.28 times the 3.28 will give me that same value of 10.7584. And then if I do the 64 divided by the 10.7584, I get a value of 5.95 meters squared. So there's the area to paint of the second house, right? The gable of the second house. The question itself asks us, right? It says how many quarts of paint are needed, and a quart covers 12 square meters. Well, both of the areas that we just found, 4.65 square meters and 5.95 square meters, are both less than 12. So I would actually only need 1 quart of paint for like one of blue and then 1 of white. Okay. Now, if we were doing it on both sides of the house, right, the first one of 4.65, if I doubled that, that would still be 9.3, and I'd still be fine. Still only need the 1, right? If I doubled the 5.95, again, I'm just coming in just under the wire of 11.9. So even if I was doubling and doing the front and the back, I'm still okay with 1 quart of paint for each. Okay. All right. So those are the applications. Again, there's the answer. So those were kind of some examples of the application questions where it's not just a matter of finding the area, you're then doing something with the area, whether that's a conversion or figuring out then how much paint you need to buy or how much grass you need to cover or how many tiles you need, that kind of a thing, right? So I've created a worksheet with, I think, 8 practice questions for you to look at, right? All on these same types of applications, right? Some with some just conversions, but everything else with an application. So the worksheet is posted on Google Classroom with these slides and with this video. What I want you to do is do the worksheets. I've also attached the full solutions of me writing out the steps of how I would solve this problem. So that when you're done the worksheet, you can compare it and say, okay, yes, I did it right, or oh no, I made a mistake and I see where my mistake is, right? Or if you're getting stuck on a question, you just don't know where to go, you can look at the worksheet and then say, oh yeah, that makes sense. But if none of that's making sense, if you're looking at a question, you don't know how to start it, then you look at the answers and you still don't know what's happening there, please contact me for assistance, okay? So I can try and explain to you what's going on a little bit better, either via email, or we can set up a Google Meet session. I can try and explain it at home on the whiteboard, okay? So that's kind of your next worksheet. You will be getting your next assignment posted this week, probably on Thursday. Yeah, you'll get your assignment posted on Thursday. It won't be due until Monday, or Tuesday, I think. You'll have a few days in the weekend to kind of chip away at that. And those questions on an assignment are going to be just on what we've done in these 2 lessons this week on area and then applications of area. Okay? So you should make sure that you're still familiar with these questions from the worksheet and from the last one in order that you're okay for your assignment, which I won't be able to go through, obviously not posting the solutions for. All right, and that's that lesson.